Welcome. Sixth Standard Science, Chapter 4 Exploring Magnets, Question Answers. Textbook is Curiosity Part 1 as per 2025-2026 Karnataka State Board Syllabus. 1 marks question. Question number 1. Which natural magnet was used by sailors in olden days? Answer. Lodestone. Question number 2. Name two metals other than iron that are magnetic. Answer. Nickel and cobalt. Question number 3. What is the end of magnet that points towards the North Pole? Answer. North Pole. North seeking pole. Question number 4. Which device is used to find directions using a magnet? Answer. Magnetic compass. Question number 5. What happens when like poles of two magnets are both near each other? Answer. They repel each other. Fill in the blanks. Question number 1. The material which is most commonly used to make magnets is iron. Question number 2. The ends of a magnet where most of the iron filings stick are called poles. Question number 3. North seeking end of a magnet is usually pointed red. Question number 4. The materials which are not attracted towards a magnet are called non-magnetic materials. Question number 5. A magnet always has dash poles, two poles, north and south. Say true or false. Question number 1. A magnet can exist with only a north pole. False. Always it has two poles. Question number 2. Like poles of a magnet repel each other. True. Question number 3. Freely expanded magnet always rests in the north-south direction. True. Question number 4. Plastic and the wood are magnetic materials. False. Question number 5. The earth behaves like a giant magnet. True. Match the following. A. Landstone. Answer is 4. Natural magnet. B. Compass needle. Third one. Used to find directions. C. Like poles. 1. Repel each other. D. Unlike poles. 2. Attract each other. E. Non-magnetic material. 5. Wood or plastic. 2 marks questions. Question number 1. What is the difference between magnetic and non-magnetic materials? Magnetic materials are attracted towards a magnet. Example, iron, nickel, cobalt. Non-magnetic materials are not attracted towards a magnet. Example, wood, plastic, glass. Question number 2. Why do iron filings stick more at the ends of a bar magnet? Answer, because the magnetic force is strongest at the poles of the magnet, so more filings collect there. Question number 3. What happens when the north pole of one magnet is brought near the south pole of the another magnet? They attract each other because unlike poles attract. Question number 4. How can you test whether a given piece of metal is a magnet or not? By bringing it near another magnet. If it shows repulsion at any end, it is a magnet because only magnets show repulsion. Question number 5. Take 2 ways to take care of magnets. Answer. Keep magnets in a pairs with unlike poles facing the same side with a wooden piece in between. Place soft iron piece keepers across the poles. 5 marks question. Question number 1. Explain how a magnetic compass works. Answer. A magnetic compass is a small circular box with a transparent color cover. Inside it, a magnetized needle is mounted on a pivot so that it can rotate freely. The north-seeking end of the needle is usually painted red. When placed on a surface, needle comes to rest along the north-south direction because Earth behaves like a giant magnet. By aligning the dial with the needle, one can find all directions north, south, east, west. What Question number 2. What are the properties of a magnet? Explain with examples. Answer. A magnet attracts magnetic materials. such as iron, nickel, and cobalt. 2. Maximum traction is at the poles of the magnet. Third one. A freely suspended magnet always rests in north-south direction. Fourth one. Like poles repel each other and unlike poles attract each other. Fifth, magnet cannot have a single pole. Even a smallest piece will have both the poles. Question number 3. Describe an activity to make a simple magnetic compass at home. Take an iron needle and rub it several times with one pole of the bar magnet in one direction. This magnetizes the needle. Pass the needle through a cork piece. Float the cork in a bowl of water so that the needle stays above the water level. The needle comes to rest in the north-south direction. Rotating the cork gently shows that needle always returns to the same direction. Thus, this works as simple compass. Question number 4. Explain the difference between attraction and repulsion using an activity with the two bar magnets. Answer. Take two bar magnets marked with north and south poles. Bring the north pole of one magnet close to the south pole of the other. They attract each other. Bring the north pole of one magnet close to the north pole of the another. They repel each other. Similarly, south pole near south pole also shows repulsion. Thus, unlike poles attract and like poles repel, repulsion is the sure test of magnetism. Question number 5. Write the steps to keep magnets safe. Why is it important? Answer. Store the magnets properly in pairs with like poles facing the same side. Keep a wooden piece between the magnets. Place two soft iron pieces, keepers across the poles. Do not hammer magnets. Do not drop them, or heat them strongly as they may lose magnetism. Proper care ensures magnets retain their strength and work effectively for a long time. Multiple choice questions. Question number 1. Which of the following is a natural magnet? Option A, iron. B, lodestone. C, nickel. D, cobalt. Answer is B, lodestone. Question number 2. Can you answer this? Needle of a magnet compass always comes to rest in the option A, east-west direction. Option B, north-south direction. Option C, random direction. Option D, southeast direction. Which is the answer out of all these four? Answer is B, north-south direction. Question number 3. When like poles of two magnets are brought close to each other, they option A attract, option B repel, option C neither attract nor repel, option D change pole. Can you tell me which is the answer here? Answer is B, repel. Question number 4. Which of the following is a non-magnetic material? Option A, iron. Option B, nickel. Option C, plastic. Option D, cobalt. What is the answer? Answer is option C, plastic. Question number 5. Earth behaves like option A, a big stone, a giant magnet, C, a rotating bar, D, a compass needle. It acts as a giant magnet. Option B is the answer. Let's enhance our learning. These are the questions from the textbook. Fill in the blanks. 1. Unlike poles of two magnets attract each other, whereas like poles repel each other. Question number 2. Materials that are attracted towards a magnet are called magnetic materials. Third one. The needle of a magnetic compass rests along the north-south direction. Fourth. A magnet always has two poles. 2. State whether following statements are true or false. A. First one, a magnet can be broken into pieces to obtain a single pole. False. Second, similar poles of a magnet repel each other. True. Third one, Iron filings mostly stick in the middle of the bar magnet when it is brought near them. False. Fourth one. A freely suspended bar magnet always aligns with the north-south direction. True. Third one. Column 1 shows the different positions in which one pole of magnet is placed near the other. Column 2 indicates the resulting interaction between them for different situations. Fill in the blanks. Column 1. North, north. Repulsion. North, this is south. Then only attraction. North, south. South, north. Attraction. South, south. Repulsion. Question number 4. Atharva performed an experiment in which he took a bar magnet and rolled it over a heap of steel U pins, as shown in the figure. According to you, which of the options given in the table 4.3 is likely to be his observation? A, B, C. Number of the pins attracted by the magnet at its various positions. Option 1, position A 10, position B 2, and position C 10. Second option 10, 10 and 2, 2, 10, 10, 10, 10, 10. All captain equally. No, what is the answer for this is Atharv's U pins experiment 4.15. More clips stick at the poles. Fewer at the middle. Answer is 10 to 10. First option is the answer. A and C are poles and B is the middle. That's why in the middle less pins are attracted. Fifth one. Reshma bought 3 identical metal bars from the market. Out of these bars, 2 were magnets and 1 was just a piece of iron. How will she identify which 2 amongst the 3 could be magnets without using any other material? Fifth one. Identify the 2 magnets among 3 identical bars. No other material. Use repulsion as the sure test of magnetism. Pick a bar X and test its ends against bar Y's ends. If repulsion occurs at any pairs, X and Y are magnets, Z is a iron. If no repulsion with Y, test X with Z. If repulsion occurs, X and Z are magnets. Y is iron. If X shows no repulsion with either X, Y or Z, X is the iron. So Y and Z are magnets. Sixth, you are given a magnet which does not have poles marked. How can you find its poles with the help of another magnet which has its poles marked? Sixth one, find poles of a unmarked magnet using a marked magnet. Bring the marked north pole near one end of the unmarked bar. If they attract, that end of the unmarked bar is a south. If they repel, that end is a north. You can mark then the another opposite one as opposite. Opposite end will be opposite pole. Seventh one, a bar magnet has no markings to indicate its poles. How would you find out near which end its north pole is located without using another magnet? Answer, suspend the unmarked bar magnet freely with the help of a thread tied at its middle so that it can rotate horizontally. Allow it to come to rest. The magnet will always align itself in north-south direction. End of the magnet that points towards the geographical north is its north pole. The opposite end will be south pole. Question number 8. If the earth itself is a magnet, can you guess the poles of earth's magnet by looking at the direction of the magnetic compass? A magnetic compass needle always points in the north-south direction. You know that. The north-seeking pole of the compass needle is attracted towards the Earth's geographical north. It means that near the geographical north, the Earth has a magnetic south pole. Similarly, near the geographical south, towards downwards, Earth has a magnetic north pole. In short, geographical north, that means upward, is a magnetic south, That's why our needle in the magnet in the compass towards the that shows the north here. Geographical south downward is the magnetic north. Magnetic field of Earth is the north. Ninth, while a mechanic was repairing a gadget using a screwdriver, the steel screws kept falling down. Suggest a why to solve the problem of the mechanic on the basis of what you have learnt in this chapter. Answer. The mechanic can magnetize the screwdriver by rubbing it several times with the one pole of the bar magnet in one direction. Once the magnetized, the screwdriver will attract the steel screws. This will prevent the screws from falling down while repairing the gadget. This method is commonly used by mechanics and electricians to handle tiny screws safely. Question 10. How two ring magnets X and Y are arranged as shown in figure 4.16. Two rings magnets X and Y. It is observed that the magnet X does not move down further. What could be the possible reason? Because they are same poles repulsing each other. Suggest a way to bring the magnet X in contact with the magnet Y without pushing either of the magnets. Answer. In figure 4.16, magnet X does not move down further because the like poles of two rings, magnet X and Y, are facing each other. In this, upper half is the north, lower half is the south, and this upper half, this side is the north and south poles. That's why they are repelling each other. Since like poles repel each other, magnet X is suspended above Y and does not touch it. To bring the magnet X in contact with Y without pushing them, invert one of the magnets. It reverse that X ring and put it inverted. Invert one of the magnets X or Y so that unlike poles face each other. Now, due to the attraction between unlike poles, magnet X will move down and come in contact with magnet Y. Question number 11. Three magnets are arranged like this on the table in the form of a shape shown in the figure 4.17. What is the polarity north and south at the end of 1, 2, 3, 4, 5, 6 of the magnets? Polarity of at the end of 5 is given. So this is given here. This pole is given. Okay, north. This is north. This is a bar magnet. So this end is the south. Second mark here. They are in contact with each other, touching each other, attracting each other means it is opposite pole. South it is. This is south, that's why this is north pole. This is north pole, its opposite is this south pole, then it is north pole. We have marked all the poles here. Again, write the answer like this. Please like, share, subscribe, comment, and save the playlist. Thank you very much. Bye bye.